Hey guys, welcome back to my algorithms video. Today is day 52 and still we're at two pointers implementation. So um we're gonna solve another question involving two pointers. Also, before starting, I just wanted to tell you guys that um because of increased workload in the past few days, I don't think it will be possible to do this algorithms challenge every day. So maybe it will be posted every 2 days or 3 days, but it wouldn't be continuously every day like this. So please bear with me. But I like this challenge and I want to do it at least until day 100, which I promised in the beginning. So um, I will make sure I come back from time to time and then uh, continue doing this. Also, I think it will be good for my long-term memory. It's better to come back in a while and refresh my memory than continuously do it while it's still in my memory, because memory is all about long-term memory is all about recalling and retrieving uh, what you know, right? So yeah, that's for that. Let me just go to the question that I solved today. Um, so question is assign cookies. So assume you're a parent and you want to give your children some cookies, but you should give each child at most one cookie. Each child has a greed factor Gi, which is the minimum size of the cookie that the child will be content with. And each cookie J has a size Sj. If Sj is Gi, we can assign the cookie J to the child I, and child I will be content. So we have an input we have an input G, which is uh, the minimum size of the cookie that child will be content with. So from G, we can already know that there's three children, and children one will be content with one cookie. Children two will be content with two cookies. Children three will be content with three cookies. Uh, and there are in total two cookies, and cookie number one has a size of cook one, and cookie number two has a size of one. So in total, there's number wise, there's two cookies, but each has a size of one. So the output should be one, because um, you can only make the child whose greed factor is one content, right? Because other two needs two or three at least. So that's why the output is one. If you look at test case two, it's the same thing. There are two children with content factor of one and two, and there are three cookies, and two, three can suffice one and two, right? So there's two in total. One can suffice one, but it is already being sufficed by two and three, so we don't take that into account. After a child is content, then that means um, you cannot make that child content again. So you just append that to the output immediately. So how should we approach this um, case? So basically what I did was um, I sorted the both lists. I sorted the both lists, and then I initialized the two pointers. In this case, we're not using the left and right pointer, or it's just we're utilizing two different pointers to iterate through the list G and this S. And while Sj is bigger than Gi, so it means that um, you can still check in the greedy factor, the children, if they will be content with the each cookie. And if one of the list exhausts, then we stop the iteration with the pointer, right? And then we save as we go through the list, as we iterate through the list with pointers, we save that output. We constantly update that output in some kind of variable. So let's do that with the code. So we're just gonna sort the list first to make it easier. So G sort and S sort. Now, we also initialize the count. So the number of cookies, number of content, children, and output the maximum number. So number of content, and I equals 0 and J equals 0. Though they are the 2 pointers that's used for iterating through the list. I will be the pointer for greedy, and J will be the pointer for the cookies. Now, so we're gonna set up a loop that continues as long as the unassigned children is there are unassigned children and unassigned cookies. So that will be while I is lesser than length of G, and J is lesser than length of J, length of S. And now we're gonna check if the cookie and child matches. So that would be if S, J is bigger than or equal to GI, then we update the count variable. So that's how many people, how many children are satisfied. So +1. We also increment DI, and we also increment the J. So 2 pointers. And we move on to the next child. If this is not the case, so if this is not the case, then what we have to do is we still just move the J pointer from the for the cookies. So whatever happens, we have to exhaust the elements in the cookie. So if this allows checking if there are larger cookies and if they could satisfy the current child. Now we after this we return the number of counts that we have saved in a variable. So that will be done by return count. So let's see if this works. Yeah, so it works. You can see that output is 1 and expected 1. Output is 2 and expected 2. I think the time complexity for this algorithm will be sorting, right? So that's n log n, 2n log n, and then there's also while loop. So that will be n square. So I think it will be 2n plus n square. And because 2n, because negligible in the long run. So I think it will be n square. Let's check the time complexity. And we can check it after we time complexity. No, it's n log n. Yeah, so I guess sorting is the most. Oh yeah, space complexity is O(n), and time complexity is n log n. Anyways, that was it for today, guys. I'll make sure, and I promise I'm gonna keep on doing this challenge, not just for you guys, but for me as well. Thank you guys all for watching, and I'll see you guys in the next video.